This is a video on graphing exponential and logarithmic functions. So we touched on this a little bit in the first video, but this will go a little bit more in depth. So the idea is that we have the basic exponential function that we all know goes something like this if it hasn't been stretched or anything. And how steep it goes changes based on the base. But if there's no multiplication up front or addition in the exponent or on the outside, it goes to the point 0, 1. So we want to look at how does that change based on some of the transformations we've talked about. So here's a good example. We've got 3 times 2 to the x plus 3. So we all know that the basic y equals 2 to the x, and I'm going to maybe grab a green, would look something like this. It would get closer and closer to 0 on this side. It would cross right there. And then from 1, since I'm just multiplying over and over by 2, it would go to 2, and then to 1, 2, 3, 4, and then to 1, 2, 3, 4, 5, 6, 7, 8, etc. That's the rough sketch of y equals 2 to the x. Okay? So what does the times 3 on the outside and plus 3 on the outside do? So just like we've learned with the other transformations, we notice that this is on the outside because it's not up here where the x is, right? Up where the x is the inside. So this is a multiplication of 3 on the outside and an addition of 3 on the outside. So we know that adding 3 just moves everything up. So it's easiest here to just move the asymptote up. So you can see there's a horizontal asymptote on the x-axis. So the adding 3 would move everything up 1, 2, 3. So then I'll put a dotted line here just so I can show where the asymptote is. And we also know that normally the y equals 2 to the x crosses 1 above the asymptote, crosses the y-axis 1 above the asymptote. Well, because of this 3, everything's multiplied by 3, that means it's going to cross 3 times as far away from the asymptote. So instead of crossing at 1, it's going to cross at 3 above the asymptote. And again, we're going for sketches here. We don't have to be real precise. So from there, we know that it's going to look something like this. It'll cross right there. And we also know that from here, it's just going to double. So we're at, it'll double this distance, right? So we're at basically 3 above the asymptote right now. So that means we're going to be 6 above the asymptote next, and then 12 above, so just keep going up like that. So you can see that this basic shape here is the same as that basic shape here. It's just been moved up, and it's a little bit fatter. So actually, it isn't the same shape. It's a little, well, I guess in relation to that it is, yeah. So there's an example of the transformations. Let me do another one. Just let's say we got y equals, oops, I forgot to change back the color. I meant to not do that in green. Okay, let's do y equals 2 to the x plus 2. Just to show you an inside move. Okay. So once again, I'm going to use green, and then I'll try to remember to change color. So y equals 2 to the x would look something like this. It'll go through 1, and then it'll double and double, etc. Go back to black now. So if I was to graph the equation written in black, y equals 2 to the x plus 2. So remember adding 2 on the inside, because this is the inside because it's with x. Adding 2 on the inside is going to move everything to the left, 2. So the easiest thing to see, that we can see this point right here, where it crossed the y-axis, I know that's got to be moved to the left 2. So I'm going to go over 1, 2, and put it right there. So that really, as what I'm going to have is, once again, it from that dot, it's going to be headed towards the x-axis. And from here, it's going to be doubling as I go forward. Etc. Okay? I did something wrong there, didn't I? Should have from here, 1, that'd be 2. Oh, then that would be 4. Yeah, it should go right there. There we go. How did I know I did something wrong? Because those weren't 2 apart. See, everything should be 2 apart. That should be 2 apart, 2 apart, 2 apart, 2 apart, because it's all been moved to the left too. Okay. So there's some example of exponential. If we change the base, let's say, let's do the same equation, y equals 3x to the x plus 2. Well, it's going to be the same idea. So there's an asymptote still at the x-axis, and we know normally a cross 1 above, but the plus 2 is going to move it to the left 2, so it's going to be 1 above the horizontal asymptote right there, and from there it should go down towards the x-axis, and from here, instead of doubling every time, it's going to triple because my base is 3. So I'm going to go from 1 above to 3 above. Oops, that should be curvy, sorry. Let me redraw that. Come up like this. And from 3 above, it should go to 9 above. 3, 4, 5, 6, 7, 8, 9. So it'll be a lot steeper. Okay? Now likewise, we should be able to graph some logarithmic equations, like if I have y equals the natural log of x minus 3, let's say. Okay? So first of all, what does the base graph look like? Well, we know that the logarithm, remember, is the reflection of the e to the x across the line y equals x. So e to the x looks something like this, right? Well, natural log of x is going to look something like this, normally. Okay? So what does the x minus 3 do? It's on the inside, so it's going to move everything to the right 3. So instead of crossing right here on the x-axis at 1, it should cross the x-axis at 4, because everything's been moved to the right 3, which means the asymptote is going to be moved to right here, because we know with a logarithm we have an asymptote. So this is going to go, and then it'll just take off like that somewhere. Right? Or if we have, let's say we have y equals 2 ln of x minus, I don't know, 1, let's say. Okay? So once again, if I want to graph that, I'm going to draw my graph here. I know that normally the y equals ln x would look something like this, right? But the minus 1 is going to move everything down 1. So let me use red just so it stands out differently. I'm going to graph this in red. So if I move everything down 1, one thing that's easy to see moved would be that right there. So I'm 1 over from the asymptote, 1 below the x-axis. So from here, I should get closer and closer to the the y-axis. And what does the 2 do? That's a multiplying by 2 on the outside, so everything's going to be stretched twice as far. So basically, it's going to get here faster, it's going to get closer faster, and it's going to get higher. Okay? So there's some examples of graphing exponential and logarithmic. There's a couple practice sheets for you to practice that. So have some fun.